Welcome to the podcast recording of Middle East AI News, live for Thursday, August 15th, 2024, brought to you by On Demand, turbocharged AI product development and integration. You're listening to Carrington Malin's discussion with Dr. Neha Sengupta, Principal Applied Scientist at Inception, the AI research arm of G42, where we talk about the Jais Arabic-centric large language model and the 20 new open-source Jais models that have just been released.
So let's dive into today's topic. In today's Thursday Deep Dive, we're going to be looking at the Jais Arabic-centric large language model and the 20 new Jais models that have been released under open source license this month. In today's show, we're going to touch on the story of the Jais Arabic LLM, the growing need for Arabic generative AI, the 20 new Jais AI models released this month by G42, how the models were developed and trained, how organizations and developers can use these 20 Jais models, and the potential impact of this open source release on the region's AI ecosystem. And I'm going to be joined by Dr. Neha Sengupta, who leads the large language model development team at Inception. As mentioned, Dr. Neha Sengupta is the principal applied scientist at G42's R&D arm, Inception, and actually joined Inception in 2018 during its very first year, I think. She leads the LLM team at Inception, bringing cutting-edge AI technology applications to the domain of Arabic and other non-English languages. Neha joined G42 after her PhD in the Indian Institute of Technology, Delhi, IIT Delhi for short. And before her PhD, she spent 3 years working at IBM Research Labs in India. So a warm welcome to Middle East AI News Live, Dr. Neha Sengupta. Thanks very much for making time to join us.
Thank you very much, Carrington, for having me here. I'm very glad.
I'm really looking forward to hearing all about the 20 new models and what they're for. I suggest we start with a bit of background on Inception and where Jais started and the sort of genesis of Jais, if you like. So Inception was, I think I'm right in saying Inception was formed in 2018, right?
That is roughly correct. Yes, it was formed, I think, in 2017, late 17, I'd say. And I joined in 2018. And actually, when I joined, Inception was, at the time, NLP had not taken off the way it has taken off now. However, we saw NLP potential pretty early, I'd say, and right from the time I started in 2018. Transformers as a model had come out pretty recently at that time. And we have always had a very strong focus here on Arabic NLP. So while Arabic LLMs are relatively a more recent thing, Arabic NLP has always been a strong area of focus. We've done Arabic-centric translation, speech recognition, OCR, and so on. And all of that, you just talked about the story of Jais. Actually, this is where it was seeded, I'd say, because all of that effort enabled us to develop Arabic data sets, Arabic expertise, that then catapulted us into a position where we could train very good Arabic LLMs right from the start.
And I believe the first Jais LLM was the 13B that was released around this time last year, right?
That is correct. That was released in August of 2023. The 13 billion parameters, Arabic-centric bilingual model trained on around 379 billion tokens total.
And that was the first, I believe, full large language model that was Arabic capable to be released in the region. And this is during the year of biggest hype around LLMs and Gen AI. Were there any particular challenges in bringing that model to market last year?
Oh, yes, absolutely. So the biggest challenge was, in fact, in developing such a model. So our goals from the very beginning was very clear. This model has to be Arabic-centric. So even if it has any other language data, Arabic has to be one of the most major languages in its training. So I think the primary challenge was the fact that if you just go online and you download data sets for English, you can find trillions of tokens. And even of the time that I'm talking about, 2023, you could find a few 100 billion or even a trillion in English. But for Arabic, that is not the case, right? Arabic data is not as aplenty. Cleaning, processing Arabic data is much, much harder. And now you want to train a model of 13 billion parameters, it has to see sufficient data, which means you can't just train on Arabic because then the model does not learn enough general capabilities like reasoning and knowledge. However, you also can't just take all of the English and add a little bit of Arabic, because then the model is just like any other model and it just forgets Arabic in favor of English. So, how do you strike the right balance? And that was the biggest scientific or technical challenge that was faced in the development of this model. And our final choice of training on 1 times Arabic, 2 times English, and zero point 0.4 times computer code was actually inspired by a large number of experiments at small scale that we did. And we finally arrived at this conclusion. It's all described in the archive paper that accompanies the release. And yeah, so once this model was trained, even fine tuning it, making sure that it adheres to safety and cultural nuances because it's bilingual, right? So safety and culture is now also has to incorporate both the English speaking and the Arabic speaking community. So taking care of both of these sides was also a challenge.
I don't want to go into too much technical detail in this show, but I've had a few questions about the architecture that Jais is built on. So it'd be useful to just touch on that briefly. And also, I'd be interested to know if that's something that's changed over the past year or whether it's still basically the same architecture as you started out with beginning of last year.
So your first question about brief overview of the architecture. So yes, it's a decoder-only causal large language model. Very similar to the Llama architecture, aside from certain differences, like we use a different kind of positional embedding in the model called alibi. And we have a different vocabulary size, of course, to incorporate for Arabic and English. And for the second question, we've trained from last year to now different kinds of models. So one series of models, which is the Jais family, still adheres to the same architecture, only changes the scale. But the other kind of model that we've trained, we'll talk about that shortly as well, is the adapted models, which are directly based on an off-the-shelf English LLM.
Also see that you're using a special tokenizer to prepare the data for training this model. Is that also something that was used last year, or is that a new thing?
So again, because we have two kinds of models now, for one of those models, we are using the same tokenizer as was used last year. And this tokenizer is trained from scratch. It gives equal importance to English and Arabic in that an equal number of vocabulary entries are from English and from Arabic. But for the second kind of models, which are adapted from an English LLM, we use a slightly different method to train the tokenizer, which is we take the tokenizer from the English LLM and we expand that tokenizer to add Arabic tokens, basically subwords, into the vocabulary. So that's a slightly different kind of tokenizer, I'd say. But you're happy to go into the details of that.
And let's just touch on the timeline. So the 13 billion parameter model came out this time last year. I believe it was the 30 billion parameter model. And then there was Jais Climate last November, December.
That's right. So just to touch upon Jais Climate, because you've touched upon an interesting concept there. So Jais Climate was a customized large language model built on top of Jais models, and it was bilingual. It was the first time we demonstrated adapting Jais models for a specific domain, which is climate, and using Jais in a more complicated setup with RAG and databases and so on, and very high requirement of no hallucinations, absolutely correct responses and so on. So that was a good demonstration of how a bilingual model like Jais can actually power certain applications.
Unlike many developers in the region, you've got a very well-recognized, respected Arabic capable model that's been out there for a year. You must have got lots of feedback from government organizations, developers, and academia. Are there any significant outtakes that have helped you build these new models?
Yeah, absolutely. So Jais models, because they've been released on the open source, have been adopted. And like you said, it's literally the only Arabic-centric model of this scale trained on this much data out there. And so it's been adopted I'd say it's been popular among organizations, developers alike. So some key feedbacks that kind of inspired this release. The first feedback was from the Arabic NLP community, particularly academia, or individual developers who were developing applications on top of Jais. And the key feedback was that, okay, we have 13 billion, we have 30 billion, these models are too large. for us to deploy on our one GPU card or two GPU cards, or we are not able to distribute this model because of certain architectural limitations and so on. So this was one developer feedback, which really inspired us to train smaller and smaller models to empower more and more people to make the decision they want between efficiency and accuracy, right? So with just large models, it's not so easy. The second feedback was about the model's capabilities itself. For example, its reasoning capability, or its ability to understand dialectal Arabic, or its ability to just generate a certain kind of Arabic diction. And Arabic is a very rich language, which means that a lot of people had a lot of great feedback about certain ways in which Jais was writing its Arabic content. And we went back and we diagnosed the reasons why it must be doing so and changed some parts of our data sets and training processes and so on to address that feedback. And one more very key feedback was the following, right? So why train a model from scratch? What is the impact, the benefit, or the loss of training from an existing model? There have been plenty of works that have taken existing models and adapted it for different languages. So why not do the same with Jais? So here we have a large suite of models that lets people decide between, as I said, accuracy and efficiency as per their needs. Be clear set of models along with an evaluation benchmark that shows the differences, the advantages and the disadvantages of adapting from a model, from an English model versus training from scratch. And C addresses many of the different Arabic specific feedbacks that was given to us after the first couple of Jais releases.
This is a very exciting time in the world of AI in the Middle East at the moment, because we've had a lot of hype in the past 18 months or so. We've had a lot of learning and planning from large organizations, what to use AI for, how to leverage Gen AI. And I think it's certainly in the UAE, probably to the wider regions, Jais has been part of that process because it's given a little window into what's possible to do with an Arabic language model. So I wanted to ask you, it's related to the feedback you've been talking about, but what do you think are the needs out there from the country, the organizations, the users for models like this?
But definitely, all of the applications that we've seen around generative AI in general also apply to Jais. For example, summarization of documents, customer interactions in both languages, particularly interactions with a dialectal Arabic speaker. Although the model does not necessarily respond in dialectal Arabic, but at least it's able to understand dialectal Arabic and able to hold conversations as a chat assistant. Then multi-document summarization, which are cross-lingual. So some could be in English, some could be in Arabic, and you want either an English summary or an Arabic summary, right? Certainly translation is a strong suite of a bilingual model like this. Then we have other kind of applications which require RAG. So Jais has been optimized for RAG, in fact, dealing with false positives in the retrieval and so on. Document question answering, for example, right? PDF, if you upload a PDF document or a certain other kind of document and you want to answer questions based on that, even embed it in, let's say, multi-agent systems, which could be where the whole system could be bilingual and so on. So there have been many suggested applications, many great ideas from the community and the organizations that we've spoken to about using Jais.
Moving on to this new generation of models. So this is version 2 of Jais. What were the goals when you set out to build a new version?
Okay, so the goals were multifold. So right now, the Jais series, the V2 release that you've mentioned, consists of 20 models. And these 20 models span different sizes, starting from 590 million all the way to 70 billion. However, this is a composition of two different, you can say, subfamilies, right? The first subfamily is 590 million to 30 billion parameters. It's trained from scratch. And all of these models have similar architecture aside from scale. They are trained on exactly the same data with the same tokenizer. The other models are all adapted from Llama 2. So you have Llama 2 7 billion, 13 billion, and 70 billion. And so we have 3 adapted models and their chat variants. So that makes up 6 out of the 20 models in the series. And these adapted models are basically, as I said, expanding the Llama 2's tokenizer to add Arabic and continuously training the model on Arabic data. As for the goals, the first and foremost goal was to enable the user of these models, whether they are developers, individual, say students or individual developers or large organizations, to take a decision as to which version of Jais they want to use, right? So this is the most comprehensive suite of non-English, non-only English LLMs out there. So they are free to choose which model they want to use. The second key thing is for researchers. This opens up a new area where in the bilingual scenario, you can study that as my model scale changes, because remember that the training data is fixed. Training data is held constant, the vocabulary size is held constant, and even the fine-tuning data is held constant. So as my model scale changes, what is the impact I see, not only on accuracy, but also cross-lingual transfer? How much does English help Arabic? How much does Arabic help English, and so on? So this is a completely new dimension for researchers to study in this. So this is a very academic goal, I'd say. The third goal is also a little bit research-oriented, which is comparing adapted models to pre-trained from scratch models and reaching conclusions as to for what situations and for what kind of downstream tasks is it better to use adapted models versus using pre-trained from scratch models. And finally, we wanted to enable things like this new way of inference called speculator decoding, which uses smaller models to speed up the generation by a larger model by deploying both together and using the larger model to supervise the smaller model. And we wanted to enable such applications in the bilingual setting with Jais models. And this is also something this release enables. Yeah, overall, I think flexibility and insight into model training and enabling certain kind of inference techniques were the main drivers of this release.
And this release contains the biggest Jais model that you've released so far, Jais70B. What differentiates that from all the others before it? Is it simply the size and the amount of data it was trained on, or are there other differences as well?
Yeah, I think the key difference is the following, right? So first, how do you expand a tokenizer? So Jais70B, our model card, describes at length how we train this model. And it is completely different from how we've trained the previous variants of Jais. So in the previous variants of Jais, the key challenge was the data. But in this variant, Jais70B, the key challenge was the training regime or the training methodology itself. So the first step was to expand Llama's tokenizer. Now, when we expand the model's tokenizer, the model has an embedding matrix. So how do you initialize the extra rows in your embedding matrix now? That is an open question. So we did a lot of study around that to make sure that we initialize those properly. And how did we do this is that we used Jais's previous model's embedding matrix to learn how to initialize the Arabic embeddings in the new Llama model by learning what is called a projection between Jais's understanding of Arabic words and Llama's understanding of Arabic words. And after doing this, now we have a model that's an English model of 70 billion parameters. I'm talking about the model that Meta released of Llama 270B, and it's trained on 2 trillion tokens. So this model knows English. We do not need to teach it more English. We do not need to teach it reasoning and other kinds of knowledge and linguistic capabilities, at least in English, right? However, we do need to ensure that in training this further and teaching it Arabic, it does not forget its existing capabilities. So to strike the right balance of adding English data now so as it does not forget English, but at the same time not adding so much that it's not able to learn Arabic now presents a different challenge. In this case, for example, for 70B, so I just mentioned for our from scratch models, we use 1 times Arabic to 2 times English, right? So if I used 100 billion tokens of Arabic, I used 200 billion tokens of English. But here I used a different ratio. So 9 times Arabic to 1 times English. So for every 900 billion tokens of Arabic, I used 100 billion tokens of English, for example. So that was the key change in Jais70B, where this is more of a adaptation exercise. However, most adapted models out there are also trained on very little data in the language they're being adapted for. In contrast, Jais70B is adapted with 330 billion tokens of Arabic, which is a large percentage of the base model's training data of 2 trillion tokens. So even the adaptation has gone on for a really long schedule. And this is what makes Jais70B really different from its predecessors.
So the Jais70B then was one of the models that you used the Llama 2 adapted tokenizer for?
That's right.
Can we just touch on open source? It's great to see this open source. Can you tell us the rationale for doing that and if this is a long-term commitment to open source?
Yeah, so we have been open sourcing, as you yourself observed, open sourcing our models for more than a year now. And I think the primary driver behind having our models open weight is that so Arabic NLP as a field, so that's the first motivation, that Arabic NLP as a field needs better models to build on top of. So we have Arabic question answering, we have all kinds of NLP tasks like sentiment analysis or entity recognition and so on and so forth. All of these tasks, although they are relatively well solved in the English space, for Arabic, they don't need better models to build on top of. And Jais provides that platform to build on top of. And second, and unless we open source, of course, the academia is not able to use it, do research on it. The second outcome of open source is the amount of innovation it spawns. So this community or the world of Arabic-centric application developers has a lot of great ideas that we think can be powered and fueled, in fact, accelerated by models like Jais being open source. We have people fine-tuning Jais for different applications, which means actually instruction fine-tuning them for different dialects and so on, even adapting them for different languages, maybe close to Arabic. And this is very encouraging. Definitely, we look forward to open sourcing our models always.
Good to hear. Lots of questions before and during this about Arabic. So let's dive into that now. First of all, common question. Can you tell us about the capability of Jais in terms of understanding and generating Arabic language text? Is this modern standard Arabic? And you mentioned the fact that it was able to understand local dialect. Is that Emirati dialect? And are there any other capabilities there to understand other dialects or output in a dialect?
Great question. So yes, Jais's Arabic speaking or Arabic understanding capabilities have been thoroughly benchmarked, not only by us, but by a lot of other independent works in the academia that have evaluated Jais along multiple different dimensions in Arabic. So all of these papers, in fact, cite our Jais papers, so you can follow those links to check those out. About the dialectal capability, Jais understands a lot of Arabic dialects, and this is mainly because our pre-training data has dialectal Arabic in it. When we apply language detection techniques on our pre-training data to filter for Arabic, dialectal Arabic also comes in. And as a result, Jais is able to understand dialectal Arabic. That said, till Arabic overall in the web also has, in the written form, does not have nearly as much volume as modern standard Arabic has. Therefore, Jais mainly speaks modern standard Arabic unless otherwise explicitly prompted or trained, which we are working towards, but we do not have, at least we have not benchmarked Jais's ability to speak Arabic dialect. Coming to understanding dialects, yes, Jais understands Emirati dialects so far that we have tested, Saudi dialect, Egyptian dialect for sure. Also, I believe to some extent the Jordanian dialect. So Jais understands, of course, Arabic has a large number of dialects and the richness is such that it's not even, the boundaries are not even clear between the dialects themselves. Similar, in fact, languages. While we have tested and benchmarked Jais's ability to understand dialect across a number of these, but actually enabling Jais to speak dialects like a native speaker is a work in progress, and we invite community engagement to enable us to do that.
Be interesting to see what the feedback is across the region on performance of Jais with local dialects. But I noticed there was some conversational data that you included in the training.
Yeah. The Arabic data that we have included in the training mainly comes from open sources. And we basically collect Arabic data from all of these sources with a prime focus on quality, essentially. When we are talking about Arabic data, processing Arabic data is slightly different from processing English data. So consider this, when you're processing an English document, if it has a lot of Arabic in it, a lot of Arabic characters in it, you might reject it because maybe it's a document in Arabic, in fact, or there's too many Arabic characters and it's going to not help your model, which is training on English data. But when you're processing an Arabic document, an Arabic web page, for example, and it has a lot of English words in it, it's not necessarily the case that this document is noisy. These words could come because even in Arabic, people write dates and names in English. Sometimes that's not uncommon. Or you might have cited some other source which is in English and so on. So processing Arabic data is challenging. It's important to focus on quality and also not allow sensitive content or troublesome content to enter your data set. Yeah, we've built a large processing pipeline, Arabic data processing pipeline, to process all of this data.
And presumably, this would be more effective in translating into standard Arabic than into colloquial Arabic.
That's absolutely correct. Yes.
So, in that data that you use for training, was there much Emirati dialect data? Because you also use the English language quite significantly in the training, right? Because there's not enough Arabic data out there to start with.
Correct. So basically, when you go up from 13 billion scale, when you go to 30 billion or beyond, or even at 13 billion, in fact, your Arabic data is not that much. Like basically inspiration drawn from OpenAI, Llama, Meta as well. A big model has to be trained on that much more tokens, right? Particularly the Llama series of models show the benefit of training on more and more data rather than scaling up the model more and more. And now, if you have only this much Arabic data, how do you induce general capabilities? Yes, if you just train on a few hundred billions of Arabic data, the model will be able to speak Arabic. However, because it has not been trained on enough data, it will not demonstrate the surprising reasoning capabilities or general intelligence capabilities that LLMs today demonstrate. And in order to do that, what we do is we add, as I said, quite a significant amount of English, in fact, double the amount of Arabic we have. This still puts Arabic at about 30% of the total training data, which is a very large number, but as such, we do have a lot of English data. What this does is that, yes, the model now knows both Arabic and English, but the amount of world knowledge and the reasoning capability the model learns through its English side is transferred to Arabic. So this is similar to how a human learns, right? I have learned all of what I've learned in the different sciences and even computer science, for example, in English. But I am bilingual. So if you ask me about AI in those other languages, I will still be able to tell you about AI in those other languages, even though I haven't necessarily read about AI in those languages. So by the same reasoning, we train Jais on 2 languages at a time or adapt an English model to understand Arabic later to be able to transfer that kind of reasoning and world knowledge into Arabic.
I suggest we spend 5 minutes just going down the new models that have been released. To start off with, this is a broad release of open source models in many different sizes with 2 different sets of training data tokenized differently. And the reason is to make it accessible to more people and have the widest possible number of developers and researchers have access to it.
Yes, that is absolutely correct.
Tell us a little bit about the different models and where you think they might fit in to a developer's needs or a researcher's needs or an organization's needs.
I'll talk about it in 2 parts. As I said, there are 2 subfamilies. So the first is called the Jais family. You'll find it on our Hugging Face page. And there are 5 sizes in this particular series. We have 590 million, that's with an M, 1.3 billion, 2.7 billion, 13 billion, and 30 billion parameters. All of these models, and the 30 billion parameter comes in 2 kind of context lengths. So we have 8,000 context length as well as 16,000 context length. So there are a total of 6 foundation models and their accompanying 6 chat models, basically, right? And sorry, I missed out 6.7b. So there's also 6.7b between 2.7 and 13. So there are a total of 7 foundation models, in fact, and 7 chat models. They share identical architectures aside from scale. They can be distributed across devices very easily. And this is addressing one of the feedbacks from before. They're very strongly bilingual because right from the beginning, they've been trained on a mix of Arabic and English. And they open up possibilities for plenty of research, foundation model adaptations. Just like we have adapted Llama 2, one could adapt these from scratch trained models of Jais for languages similar to Arabic, for example. These models all are, as I mentioned before, trained on exactly the same data. So there's a plenty of evaluation around all of these models on our model card, which shows you that as model scale changes, what happens across different dimensions of evaluation. So this is 14 out of the 20 models. The remaining 6 are adapted from Llama 2. There is Llama 2 7 billion, which is trained to Jais adapted 7b. 13B and 70B, each coming with a chat model variant. And again, these models are more suitable for applications which require stronger English support, but definitely are Arabic centric. So strongly bilingual applications where you also need extremely good performance in English because it's derived from Llama 2 without compromising on the existing English capabilities of Llama 2. These are actually pretty powerful models there. 70 billion, just because of its sheer scale, also demonstrates very strong reasoning capabilities, both in English and Arabic. So this is for large enterprises who have the capacity to deploy a model of this scale for high precision applications and those requiring very strong reasoning skills.
Now, I think I saw mention of Android and iOS on the website. Where could you deploy these models? And does that imply that it's possible on a mobile phone, or are we talking laptop?
The smaller models are deployable on laptop. For mobile phones, we are also exploring. I think the Android or iOS discussion comes from the fact that we have a Jais chat application that's supported on the mobile phone as well as the web page. And essentially, it's completely free. You can go and sign up and you can start chatting with Jais in both languages, with more languages to come soon. And we have different kinds of user experience optimizations as well on the Jais chat application. So yeah, that's where the iOS and Android discussion comes from.
So otherwise, the smaller models, you could run them on a powerful laptop.
Yes, you could. 590 million, 1.3 and 2.7 billion. We also have, the community has done plenty of great work around this. I think even up to 6.7 billion, it's possible to run just on your laptop.
Thank you so much for joining us today, Neha. That is really fantastic. I learned a lot.
Thank you very much, Carrington, for having me. And I also enjoyed this session quite a bit. Thank you.
I've been talking to Dr. Neha Sengupta, Principal Applied Scientist at Inception, the research arm of G42 Group.
You've been listening to a recording of Middle East AI News Live for Thursday, August 15th, 2024, by Carrington Malin, brought to you by On Demand. Thanks for listening.